Okay, and second product I'm giving Nokia, and third STC, and fourth Sony, right? Okay, so I'm saving this as in documents in pic. I'm creating a folder giants, right? I'm saving this as prod info. Save this file. Okay, I'm taking another file. It's a user info, right? Ajay using Ajay, press tab 1, and Rekha 2, Shiva 3, Ramanan 4, right? Shreyas 5, right? Some, right? Again we'll see Ajay 6, Shiva 7, right? I'm saving this as user info. Okay, we have two files. One is prod info, another one is user info, right? We'll run this in the MapReduce mode. So I'm copying this file, Hadoop FSFN, city documents, and in the peak we have a directory giants. Right, I'm copying these files to Shiva directory, Hadoop FSFN, put, user Hadoop Shiva, correct? Right now I'm copying the files to the SDFS so that my input data is available in SDFS. Right, Hadoop FSFN put, what is the files which we want to copy? Right, prod info, user info. Prod info file already exists. See, product, right? Product info. Give. Okay, user info is already copied. So you'll see this Shiva directory, right? User info, right? Users are there, and other file is product info. The products are there, right? Now my input data is available in SDFS, so that now I can able to run pig in a MapReduce mode, right? So to run pig in MapReduce mode, write pig-x MapRed. Okay, now we have to load the data. So I'm writing prod info equal to load. So from where I have to load the data? From SDFS directory, user Hadoop Shiva I have a file product info, right? I want to load this as, so this product info contains id and string, right? Prod id is an integer, comma, prod name is a char array, right? You can see describe prod info, right? Now we'll see dump prod info,
Ajay?
Reka, yes Reka.
Yes, I have a question. So while mentioning the path, load user Hadoop, right? So why don't we mention the HDFS colon double slash localhost, right? We are directly writing the path user Hadoop,
Right,
Shiva.
right. Prod info load, right? So here HDFS colon slash slash localhost colon 8020. You can use like this. It's up to you.
I think like
Okay.
since it is in the same machine, we don't need we don't need the IP address, I guess.
Yes, because see, we can access a file system using two arrays. One is a local URI and other one is you can use HDFS array. We can access with the same, right? Otherwise you can use 0.0.0. Right? Otherwise you can use 127.0.0.1. Right? The thing is how you identify this. Open 50070, right? 8020. This one, right? If you have a, otherwise go to the live nodes, right? So this is a local host, right? You can see one. You can see this 127.0.0.1, right? The machine where you have configured the name node, right? The data node is available and this 50010 and 127.0.0.1. Okay, now you can use this. Expecting semicolon, right? Prod id is an integer and prod name is a
Carrot.
char array.
Yeah, missing as.
Yes. Okay, now info. right? The same thing now we write for user info, right? Okay, right. See, you're given product info, right? Next, user info. So what are the fields we have? Is the user info, right? The first one is username and the product ID, right? Username, char array, okay, comma, prod ID is an integer, correct? Now load user info. Okay, we load both again.
The file name is different, right? The user info file thing.
Correct. For
Ajay, again, the name is wrong.
wait,
User info, you have put 2O.
okay, right. We load it again. Right now, right, dump user info. Okay, now see here, I'm writing a giant. Suppose if you want to write the inner giant, so what are the giants? So when we are writing the giants, so we need to have a common column between the two tables, right? So I'm writing some giant user prod equal to. So now I have to join. Which one I have to join? The table first relation prod info. So what is the common field in the both the tables? Prod ID, right? Here the prod ID is the first field. So right, join prod info by $0, comma, user info by, here the prod ID is the second field, right? That is $1. Right, so here I'm writing user prod equal to giant prod info by $0, comma, user info by $1. Copy this, edit, paste, right, press enter. User info, what is error?
Yeah, why
Yes, form. Right now, write dump user start. Okay. Okay, Shiva. So in this way, we can join the two tables, right? So now when you write this, it's like inner join.
How
Suppose
to avoid those IDs
which one?
in the output? Like we do see IDs as well, right?
Right, we have wrote right. Suppose if you want to avoid that one, you have to use whatever is there replicated. You can use that keyword. See that you want to avoid which one? This repeated one, right?
Yeah.
Right, we can do that. So suppose if you want to go for left outer join, see what are the left outer join? All the elements in the left table are going to match with all the tables in the right table. So if it find any match in the right table with the left table, they are going to be displayed, correct? So the same thing for the right outer chain, right? All the elements from the first table are going to match with the second table. If it find any matches in the left table, so it will display with the right table values. Full outer join means what? From both the sets, it will take all the common columns. Correct, Shiva? Suppose if you want to write this one is a left outer join, then you can write join by $0. Then here write left space outer. Okay. So join prod info by $0 and then write left outer join, comma, and we are user info by $1. Temp user prod. Okay, it's a left outer chain, right? So the last row doesn't find the matches, so it's an empty, correct? So let me check with right outer chain. So if you write right outer chain, write RIGHT, right, by $0, edit, paste, right? This is right outer chain. Now you can write dump user prod. Okay, So it won't find this matches in the left table, it's an empty, and so these are the right. Okay, so it's a right outer join. Suppose if you want to write the full outer join, then you have to use the word full. This is the right here, full outer. Right now, write dump user prod. Okay, this is a full outer join. Right, suppose if you want to write the Cartesian product, what's the Cartesian product? A comma B cross B comma C means all the elements from this set are going to match with every element in the second table set. Right, A cross B, A cross C, B cross B, B cross C. Like it's a Cartesian product, right? So for this we have a function cross in, we have operator cross which performs Cartesian product. That is, all the elements of prod info are going to match with every element in user info. Right? For this you have to write cross. Right? You have to write cross user info, comma, sorry, prod info, comma, user info, dump user prod. Right? This is Cartesian product. Okay, Shiva. Right? So to write this, you have to write cross prod info, comma, user info. Right, so either it can be hive or peak. Apart from this inner join and outer joins, so we have an extra join, that is map set joins. Right, to make the so we use these joins. So if you want to process these giants to the mapping phase, suppose what we'll do now, when we are writing the map set giants, so we always load the small table first into the memory, then we are trying to join with the other table. Right, so suppose if you want to use the map set giants, we use the word replicated. Like the same thing you can write user prod equal to, write join prod info by $0, comma, user info by $1. Okay, now see what we are doing here. We are using these giants as in pig. It is a fragment replicated giants. Okay, we call it as fragmented replicated giants, right? So these are the giants which we call it as map reduced giants, or the map side giants, right? So we'll see more about this fragmented the map reduced giants when we discuss in Hive. So we'll dig deep into these giants, right? As of now, see we see how we use these giants, right? By $1. Now specify here using, now I want to use replicated giants, correct? So use the word replicated. Okay, suppose consider, so when we have to use, suppose we are going to join the two tables, right? So where we are having maximum number of records are there in the each relation, right? Because it's here, it is we have the small data, so we doesn't have a big issue, right? But so there are the two data sets are there. Now you want to perform the join between the two data sets, correct? Now suppose if a data set one, a relation one contains some 5,000 records, and another set contains some 10,000 records, right? Now I want to perform the join between those two tables, right? Now when you want to perform these joins, now how much memory you are allocating to, right, for this map reduce jobs may not be suitable, correct? So instead of loading the big table, right, into the memory to perform the join with other table, so these fragmented replicated joins are these map reduce job giants. What will do, so one, the the data which is small one, right, the data set or the relation which contains small data will be taken into the memory, and so this data which is less number of records are loaded into the memory and are going to match with the other relation with each and every element, right? So this kind of giants we call it as map side giants, or in pig we are calling it as fragmented replicated giants. Okay, so what it will do now, when you write this replicated, so what it will do now, it will distribute the small input to all mappers, and it performs the giants from the map side. Okay, so you can see this, right? Giant prad info by $0, comma. Now write dump user prad. You can check more about this map side giants in Hive. Okay, so these are the map side giants. Yes, we have to use the word replicated. So in Hive, we'll write a small comment line, map site, that's it. Okay,